Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of intersection of events and multiplication rule. So here we've got two events, A and B, and they are defined in a sample space. So when you have the intersection of A and B, it represents the overlapping area between A and B. So here are the area where they share the same elements. So they have the outcomes that are common to both A and B, or in other words, sharing the same elements. Now the notation used for intersection of events are A and B. Sometimes you have this symbol here, so that represents the intersection of A and B, and sometimes it can be just commonly written as AB, so we know that this is A and B happening together. Okay, so when you want to find the probability of A and B happening together, so in other words the joint probability, then the notation used will incorporate the word P here. So here is probability of A and B happening together. Okay, so we've got P right in front of this term. Okay, now to find the probability of the intersection of events, the probability of A and B, you can use this formula, and this formula is known as the multiplication rule. How this formula is obtained? Well, it comes directly from the idea of conditional probability, which you have already seen in the previous video. So what is conditional probability? So it is defined as probability of B given A. So A has already happened. A has already happened. So what is the probability of B given A has already happened? And I have told you how we can construct the formula to find the conditional probability of this event. So the top part here is going to be considering both events happening together. So we are going to have probability A intersect with B or B intersect with A, doesn't matter. Okay, so here at the top part is the joint probability, and at the bottom part here we're going to supply the information right from this event that has already happened. So A has already happened. You should be able to tell what's the probability of A, and that information is going to be supplied right here. So that is P, probability of A intersects with B over probability A. And from here we can see that you might be interested to find what is this probability. So what is this probability? This is the joint probability, and using the multiplication rule you can actually consider, for example, the right hand side here be multiplied with probability of A, and in order to make sure the equation here is balanced, the left hand side also must be multiplied with probability of A. And because of that, this can be cancelled out, and you will find that probability A intersects with B is going to be PA times PB given A. So we have the process of multiplication over here, and that's why it is known as the multiplication rule, and this is what you have right here. Okay, right, let's move on. Now, the following table gives the classification of all non-academic staff of a faculty in a university by gender and bachelor degree. So we've got male and female, and here we've got bachelor degree without bachelor degree. So if one of these staff is selected at random for membership on the staff welfare committee, what is the probability that this person is a female and has a bachelor degree? Now, the good thing with having the information in a table like this is you can find the answer straight away from the table. You don't need to really be concerned with this formula here. So if you want to find the probability the person is a female and has a bachelor degree, and the keyword here is and, this is clearly the intersection problem. Here we have to find the probability of female intersect with that person having a bachelor degree. Okay, so since the information here is given by table, we can clearly point out the position where there's female and there's bachelor degree. So here we've got 4. There are 4 number of female with bachelor degree, and 4 is going to be divided with the total number of subjects in that sample space. So 4 is going to be divided with 40. Yes, and so in this answer, for this one, the answer is going to be equal to 0.1. So this is the probability of A and B. Okay, the probability of 2 events in general. Okay, now let's move on to the next formula, where you know that in addition to this formula here, so you see this is the original formula of multiplication rule. So what is multiplication rule? Multiplication rule is this one: A intersect with B is equal to P A times P B given A. So this is what you have already seen in the previous slide. Yes, so this is multiplication rule. Now let's say you have additional information. Let's say that you just know that A and B are independent. So this formula is the formula that you use when they are dependent events. Dependent. Okay, A and B dependent. So if they are independent, if we know that they are independent, you can see that this general formula here will be reduced to this one. So it becomes this one. Now, how do we get from this original multiplication rule to some sort of a simplified version here? Now, remember when we talk about the idea of independent events. Okay, so in the previous video we talked about the idea of independent events. So independent events is if you have A given B, probability of A given B, it will be equal to probability of A, because whatever happens here, it will not change the probability of A happening in the future. So B doesn't really play a role to change the probability of A. So probability A given B is going to be equal to probability of A. So in this case, if we have additional information that A and B are independent, so when A and B are independent, this part here is going to be probability of B given A is just going to be equal to probability B, because it doesn't matter what happens right here, doesn't matter what happens for event A, the probability is not going to be changed for event B. A is not going to affect the probability of getting event B. Therefore, we can replace B given A, the probability of B given A, with probability of B, and that's why we have it right here, just probability of B. Okay, so this formula can only be used if you know that A and B are independent. So only use it when they are independent. All right, let's look at some example. So here a university has 2 fire detectors. The probability is 0.04 that any fire detector of this type will fail to go off during a fire. So this is the keyword that somehow tells you that the event here is independent events, because the fact that one fire detector failed to go off doesn't influence another fire detector fail to go off. So So it's saying that the probability is the same for all fire detectors. Okay. Now, find the probability that both of these fire detectors will fail to go off in case of a fire. So there is a failure in that. I'm going to define my event as such. I'm going to say that A is the event where first fire detector fails to go off. Okay, so that is my event. And I know that probability of that happening is 0.04. Next, I'm going to define the next event. B is the event where the second fire detector fails to go off. And it says here that the probability is also going to be the same, because it says here any fire detector will fail to go off, the probability is 0.04. So it indicates that the probability here is the same. So it's going to be 0.04. Okay, so right now we can visualize that the question is wanting you to find out the probability that both will fail to go off. So you're talking about the intersection problem, really. So it is asking you to find what is the probability that A and B happens together. So what's the joint probability of A and B occurring together? And you can see that the idea is going to be simple because they are independent events. How do we know they are independent? Because the probability here is the same. It's not going to change regardless. So you know that this is actually PA times PB, and in this case it's going to be 0.04 times 0.04, and the result here is going to be about 0.0016. So that's the probability of A and B happening together. Now, if you find this a bit difficult to understand, as I've always said in my previous videos or during our meeting, you can try and visualize the problem using a tree diagram, and perhaps that will give you more insight, more idea as how you can approach this the solution to this problem. Okay, so let's try and visualize this example here using a tree diagram. So you can imagine this is the first stage. Okay, this is the first point where we're going to see if fire happens, what will happen to the first detector. Okay, so let's imagine the scenario where there's fire and you want to see how the first fire detector behaves. So we're going to see at this stage, see what happens to first fire detector. So at this point, you can see that A might happen. There are two options here, or A prime. So A here is the event where first fire detector fails to go off, and the probability of that happening is 0.04. So A prime here basically means first fire detector will go off. That means it works. Okay, the first fire detector works and it will go off. Therefore, the probability here is going to be 0.96. It is a complementary event, so the probability here is 1 minus 0.04. You will get 0.96. So that's the process. We see what happens to the first fire detector. And imagine you come to this second stage here, where you want to see what happens to the second fire detector. Okay, so in this case, you can observe two scenarios. You can observe B event, where B is the second fire detector also fails to go off, and the probability is the same, 0.04. and this is the complementary event, which means the second fire detector works, it goes off, so it will be 0.96. Okay, similarly, this is what is going to happen. We have got B event 0.04, and here is 0.96. And if you follow the thought process which you have seen, you know, when you were in school, when you were studying this type of probability problems or examples, now you can see that this path here is the path where you observe A and B. Okay, and this one is where A and B prime, that means A fails, the first fire detector fails, but the second fire detector works well. This one is the combination of the first fire detector works, but the second fire detector fails. Okay, and this one is the event where both fire detectors actually working well. Okay, and we are interested in the event of both of them fail. Okay, so both of them fail, both of these fire detectors fail to go off. So we are interested in this event A and B. Fails to go off, fails to go off. So we are interested in A and B happening together. So this is the only event that we are interested with. Both of them fail to go off. Therefore, we have learned in a simple example, simple probability or simple tree diagram. In order to find this probability, just need to multiply the path, the probabilities related to the path given here. So the probability of AB is going to be 0.04 times 0.04, and the answer is going to be 0.0016. Okay, all right. So remember that whenever you are given a question and you are like kind of stuck and you're not sure which formula to use, try to perhaps visualize the problem in terms of a tree diagram, and from there you might be able to get the correct answer. Okay, okay, let us move on to the idea of joint probability when the events are mutually exclusive events. Okay, so again, the joint probability, as I said to you, excuse me, the joint probability, to find the joint probability, you use the multiplication rule, which is, for example, you want to find A intersect with B. This is the original formula is going to be PA times with PB given A. So this is the original formula. Yes. Now, what we have done so far is, let's say you know that A and B, sorry, let me just erase this. Let's say that you know you have further information where A and B are independents. So when A and B are independents, probability A intersect with B is just PA times PB, because this one here is going to be when they are independent, doesn't matter what happened to A, it's not going to change the probability we get for B. So therefore we got probability of B right here. Now there is another case. What happens if you know A and B to be mutually exclusive? So if A and B are mutually exclusive in this case, then automatically probability A and B is going to be 0. So it makes sense really. If there are mutually exclusive events, there will be no intersection at all. So when there is no intersection, that means the probability is going to be 0. So consider the following two events for an application filled by a person to obtain a personal loan. So A here is the loan application is approved, R is the loan application is rejected. And the question is asking you to find the probability of events A and R occurring together. So probability A intersect with R. And clearly, because the nature of events here, you can see that the nature of events here are actually mutually exclusive, because you can imagine there is no way the loan application can be approved and rejected at the same time. These events cannot happen together. So these events cannot happen together. So when they cannot happen together, we can say that these are mutually exclusive events. So if they are mutually exclusive event, the probability of them happening together is going to be equal to 0. Okay. Right, let's look at this example here. This is quite a classic example where you have to draw random chips. Okay, twice. You draw one at random and another at random from those that remain. So here we've got a bowl with 3 white and 5 blue chips. So what's the probability that you get one of each color? Okay, and again, like I said earlier, if you find it difficult to decide which formula to use, and what you can do is you can try to visualize this problem in terms of a tree diagram, right? And this is our starting point. Okay, so we're going to try and visualize this in terms of a tree diagram. So here will be the first stage where you're going to define the process here as draw the first random chip. So you can imagine a bowl with white and blue chips. Therefore, when you draw the chip at random, you may get either white chip or blue chips. Yes? You imagine that process in your head. Now, let's think about what's the probability of getting the white chip. So the probability is going to be how many number of white chips that you have over total chips that you have. So probability of getting a white chip is going to be 3 over 8. And the probability of getting blue chip is going to be 5 over 8. Okay, so I hope you can see that this probability, when you add them up, it's going to be equal to 1. Okay. Next, we have arrived at this junction here. So this is the second stage. And so at this second stage, we're going to see the result when you draw the second random chip, and you draw that from whatever that is remained in the bowl. Okay, so that means when you have done this first stage here, the number of chips in the bowl is going to be reduced to 7 because 1 is already taken out. Therefore, the number of chips, the total number of chips in the bowl is going to be 7. Yeah. And you imagine this process happening at the second stage. Of course, you may get either white chip or blue chips. And like I said to you, the total number of chips is going to be 7 because you have already taken 1 chip here at the first stage. So if you, for example, in this case, you have come to this junction where you have taken 1 white chip. So 1 is already taken. That means you are left with 2 white chips. So the probability of getting white is going to be 2 over 7. And for this one, since you come from this junction, you have already taken a white chip. That means the blue chips are still at this value. The number of blue chips is still going to be 5. So here is going to be 5 over 7. So that's the probability of getting a blue chip given that you have taken a white chip. So this is 5 over 7 plus 2 over 7. You should take note that the probability should be equal to 1. Now let's move on to this stage here. So here we can also get white chip and blue chip. Okay. And this is the junction here where you have considered taken 1 blue chip. Okay. And you keep the chip with you. Okay. So therefore, the number of chip that is in the bowl is going to be reduced to 7, and here is also reduced to 7. Now if you have taken the blue chip, so this is the junction where you have taken the blue chip. If you have taken the blue chip, that means the white chip is still at this number, which is, it's going to be, probability of getting white is going to be 3/7. And again, since you have taken the blue chip already, therefore the blue chip is going to be reduced to 4. So here is 4/7. So those are the process that you can come up with when you consider a tree diagram to illustrate this example given here. Now before we go on to answer the question, okay, this original question, let me just explain to you once again the idea of perhaps conditional probability, just to make sure that everybody understands the notation of conditional probability. Where is it really? Okay, what is it really? And the idea of joint probability. Okay, so for example, this value here 2/7, what does it mean? Okay, this value here 2/7 is the probability you get a white chip given that you also get the white chip at the first stage. So that is, this value is a conditional probability. Or for example, this one. Okay, this one. What is this value? 3/7. 3/7 here is the probability that you get white given you have obtained a blue chip. So probability that you get white given that you have taken a blue chip. So that is 3/7. So that part here is conditional probability. Okay. Now, what is joint probability? Joint probability is you, for example, getting blue and white together. So now I'm just going to illustrate to you joint probability. So for example, for this one here, I'm going to talk about this specific path. So this is the probability of getting blue and white. And if you follow the idea of simple solving probability problem, you're just going to find 5/8 times 3/7. So this is 5/8 times 3/7. Oh god, let me just erase this part. And this is equal to 15/56. Now I'm going to explain to you what is 5/8. 5/8 is probability of getting blue chip. And 3/7, as I have illustrated to you here, this is actually times with probability of getting a white chip given that you have drawn the blue chip. Okay, so I hope you can see that this part here, this formula here, it looks like the multiplication rule formula which you have seen in the previous slide, where you have P A intersect with B is actually PA times PB given A. Okay, so we have A right here at the end. It has already been observed, so here we've got A. So similarly, we've got B at the end here, which means it has already happened, and therefore we've got probability of B next to this conditional probability. So what I'm trying to show you here is, I'm just trying to make sure you understand that this notation here where is it really, being represented in a tree diagram. Okay, so the tree diagram represents all this notation which you have already seen in the previous slides. Okay, just to make sure that you really know what is conditional probability, what is the joint probability, and so on. All right, let me just erase all this and we go back to solving the original question. Okay, god, okay, hang on. Oops. All right, so now if we go back to our tree diagram, we can see that for this path here, we are considering the event of W and W joining, happening together. This event is W and B together. This is B and W together, and this is B and B together. And the question is asking you to find the probability you get one of each color. That means you can either get B first and then W. Okay, so B and W, or you can get in a different order, which is white first and then blue. So we are actually looking at this path, this one and this one. Okay, so this path. Okay, so we need to find what's the probability of that. So the probability of this white and blue is going to be 3/8 times with 5/7, which is 15/56. Now for this one, the probability of getting blue and white, okay, it's going to be 5/8 times 3/7, and this is also going to be 15/56, and you got to add up these two probabilities together, then only you will be able to solve for this question here, probability that you get one of each color. Therefore probability you get one of each color is going to be 30/56. And if you want to do it in terms of numbers or 4 decimal places maybe, so this is going to be equal to 0.5357, so using 4 decimal places. Yeah, okay, I think that's all for now. Thank you very much for watching.